Hello, so today we're going to talk about the action of lovastatine on cholesterol biosynthesis. So what we're going to say first is the biosynthesis of the cholesterol. So here we're going to have like some of the different mechanisms that we are going to have for like converting cholesterol. So first of all, we're going to see the most important thing is the HMG CoA that is going to be the first step for converting to mevalonate. This mechanism of this first step is going to be made by this enzyme that is going to be really important on this presentation. Since we are going to talk a little bit later, HMG-CoA reductase. And then we're going to have different steps that they're important as well, but they are not really main well on here. Anyways, we're going to mention some of them as we were saying before that they're considered important too, like the conversion of the 5-pyrophosphomevalonate to isopentyl pyrophosphatate, because after this conversion is going to be the dimethyl pyrophosphate, which is going to go into the second part of the transformation to a cholesterol because it's gonna go taking different phosphate groups. So after that, we're gonna have that the isopentyl pyrophosphate is gonna join to this process and is gonna make this esqualene, which is going to be a really ramific structure on this step. And then like after that, the esqualene is gonna convert on this oxyesqualene, taking out some NADPH for like going into the last steps on this that is gonna be converting into lanosterol and finally into the whole structure of the cholesterol that we can see is like really that it has different structure and different rings, so it's kind of long and complicated. But what is important here, as we was saying before, some of the important enzymes on this one is the HMG CoA reductase, because it's the first step and it's like the first conversion to getting this cholesterol. So first of all, we're gonna see that the MCA is really important, especially because like this catalyze the rate limiting of the cholesterol synthesis. So this means that is going to be that is going to be kind of like the control on these different reactions, or in the first step to go into convert cholesterol is going to be short-term control enzyme by competitive inhibition. That this is important because it's just a short-term control. So this means that it's not going to be really long when we are talking about the different control on this enzyme. And then we're gonna see that it's allosteric and it's gonna make like different covalent modifications in the rings and in the different bonds on the molecules. And then the first mechanism is going to be the first mechanism of activity on is long-term feedback control, and it's gonna have this control of the amount of the enzyme present in the cell. So this is going to be really important, especially when we talk about different treatments that they are gonna inhibit these mechanisms. So that is why we're gonna see that one of the most important things here is the hypercholesteremia. And why we are mentioning this is because like this enzyme is really important, especially on this kind of disease, and especially because like different drugs called as like statins are gonna go to inhibit this type of enzyme. And this is really important because like the statins as a competitive inhibitor, as we said before too, like the HMG CoA reductase is a competitive inhibitor, but since the statins are gonna go into the different treatment of this, there are gonna be two competitive inhibitors trying to not to inhibit um, this modification on the enzymes to the NGCOA and binding tightly to the enzyme before the other enzymes. The X-ray structure revealed that statins have a bulky hydrophobic groups that disrupts enzyme activity without interfering even in the NDHPH binding. As we saw before, like the NADPH, here is something that is happening right now. Like we are gonna have two molecules of NDHPH for forming two molecules of NDP plus, which are gonna make this SCO-A2. So this kind of binding is not gonna make any modification on this kind of a structure. So that means we're not gonna take any kind of energy here. The enzyme adapts its conformation to accommodate statins, forming the extensive van der Waals interactions, leading to a strong inhibition. So we're gonna see that science. We are gonna have this kind of that's kind of statins like inhibiting this function of this enzyme. We're gonna have this strong inhibition that is gonna even like have different interaction on the van der Waals forces on the molecules, since we saw too that they can make like covalent modifications. This is gonna be like a something really important, especially talking chemically on the structures of the different metabolites. Physiological response, we're gonna see that is gonna decrease the cellular cholesterol and is gonna increase the LDL receptors of expression. More LDL and EDL is gonna removal from the bloodstream and lower serum LDL cholesterol levels. So we're gonna see after this that this is gonna to be really important, especially for the mechanism of action of the different statins. Like as we said, as we mentioned to the statins, one of the statins is the Lovastatine. That is why it's really important here. The Lovastatine is it has like different brand names at Vicor, Altoprev. The generic name is Lovastatine. The summary, we're gonna see that this is an inhibitor user to lower LDL cholesterol. As we mentioned here, we're gonna see that this kind of physiological response is gonna have the more LDL and EDL removal from the bloodstream. So it's why we're gonna need more. We're gonna remove the for the bloodstream more LDL and EDL. So this means this kind of drug is going to inhibit the use of the lower LDL cholesterol and is going to reduce cardiovascular conditions, including myocardial infarction and stroke. Some of the background is that this drug is also known as a Mevacor, and it's a lipid lowering drug and is associated conditions with the apolipoprotein, with the cholesterol LDL, and the coronary artery atherosclerosis as well as the hypercholesterolemia. The mechanism of action of this one is the most important thing that we're gonna mention here. As we said before, the Lovastatine is gonna make like the action on this specific enzyme, the HMG CoA reductase, which is gonna be the conversion of this compound to the mevalonate. So Lovastatine acts primarily in the liver, where it's gonna decrease the hepatic cholesterol concentrations and stimulating the upregulation of hepatic low density lipoprotein, which are gonna be the LDL, the receptors, which are gonna increase the hepatic uptake of LDL, um, like these ones. So the Lovastatine also is gonna inhibit the hepatic synthesis of very low density lipoproteins as the VLDL. So this overall effect is gonna decrease in the plasma both LDL and VLDL, which are two different kinds of lipoproteins, and are gonna be a significant reduction on the risk of the develop of CVD and all causes of mortality. So some of the things that are significant effects on the LDL-C reduction uh, on different research are seeing that within 2 weeks of initiation of this treatment of the Lovastatine, are gonna be have a response within the 4 to 6 weeks. The response is gonna maintain during the continuation of therapy and is going to be a single doses on the same doses given on the morning or like normally synthesizes on the night. When the therapy of the Lovastatine is stopped, normally we are gonna see that total cholesterol has been shown return to the pre-treatment levels. So it's kind of dependent drug that you need to go to take in. So Lovastatine like has reported to like having different beneficial effects on cancer. This includes more multifactorial stress triggered like cell death and DNA degradation responding breast cancer cell. And it's also shown to inhibit histidine diacetyl 2 activity and increase the accumulation of acetylate histidine and the expression of P21 in human cancer cells. So this suggests that statins might serve as novel HDAC inhibitors for cancer therapy and chemo privation. So nothing like here we have the one of the three important ones, the statins that are going to be really important. First of all, the one that we talk on this presentation that is going to be the Lovastatine. Another ones that are important too on this one is the Pravastatine and the Simvastatin that at the end of the day they're going to be important as well. Thank you so much for your attention.